right, today we're going to look at a couple example problems from the homework, and I'm going to work them out, and you can work them with me or you can watch and check against your own homework. In the first problem, we have been given 26.4% carbon, 3.3% hydrogen, and 70.3% oxygen. And every time you're given percentage, remember that percentage is equivalent to grams because we'll just assume that our whole sample is 100 grams. So when that happens, we just take our percent sign, we turn it into G's for grams. And so I'm just going to go ahead. I've listed my elements, carbon, hydrogen, and oxygen. I have taken my percentages and turned them into grams, so 26.4 grams of carbon, 3.3 grams of hydrogen, and 70.3 grams of oxygen. I then divide through by the molar mass for each element to get moles. Remember, in our mole road map, when we're going from grams to moles, we divide. So that's why it's in the denominator. So 26.4 divided by 12 is going to give me 2.2 moles. 3.3 divided by 1 is 3.1. And 70.3 grams divided by 16 is 4.4 moles. I then select my smallest number of moles, which is 2.2, and I set up all my fractions with this as the denominator. So 2.2 divided by itself is always 1. 3.3 divided by 2.2 gives me 1.5. And 4.4 moles divided by 2.2 moles will be exactly 2. So what I do to one thing, I have to do to all of them. And I see that my half fraction is here. And if I multiply that by 2, that's going to round me to 3. And then the carbon becomes 2 and the oxygen becomes 4. So these are my new subscripts. And down below I have written C sub 2, H sub 3, O sub 4 as my empirical formula. So I guess that actually goes right there on that line. The next thing I have to do is determine what the molar or the molecular formula is. And in this case, I add up my empirical mass. 2 times 12 is going to give me 64. Plus, 4 times 16 from the oxygen gives me 64, plus 3 hydrogens plus 24 grams from the carbon gives me 91 grams per mole, which is exactly what I have. And so my empirical mass or formula is the molecular formula. So my molecular formula is still C2H3O sub 4. Okay, so that's problem number 1. In problem 2, this took a little more figuring. Even though we just have carbon and hydrogen, we ended up with 6.82 moles of carbon, 18.2 moles of hydrogen. Carbon is my fewer number, so this becomes the denominator in my mole ratios. So 6.82 divided by itself is 1. 18.2 though gives me 2.66. Now I need you to stop for just a moment, because when we are dealing with these things involving fractional moles, there's actually a little trick to it. So if you take and look at it this way, where I have x equals whatever my integer is, if I end up being 0.9 or greater, that number is going to round up to the next whole unit. Down here, x.1 or x.15 or something like that, that's actually small enough that we can just round down, just keep the number as is. So if you're at 0.1 or 0.9, you either round down or round up. And then, as we have seen before, if our fraction is 1/2 or 0.5, if I multiply that by 2, that's going to go to the next whole integer. But what about when it's in between these zones like this? You don't want to just ignore it, and you don't just want to round. You have to consider that just like 0.5 was half a mole, and so if this were, for example, 1.5, then that zero point 0.5 times 2 gives us 1, which then adds on to whatever is in front of it, and that gave us our whole number. But what if it's something like this? If x is 0.25 or close to it, that's actually 1/4 of a mole. So in this case, I'm going to multiply by 4, and that's going to take me to my next whole integer. If I am at x 0.33, that's 1/3, so I'm going to multiply that by 3. And then if I end up over on the other side, it's just the same thing. X 0.66 is 2/3. So once again, I'm going to multiply by 3. And x 0.75 is again 3/4. So I'm going to multiply by 4 in that case. So you see a pattern? We have effectively times 1 times 4, 3, 2, 3, 4, and then we're just back to keeping it as the same and rounding up. All right, so in this particular case, when I do my math, I ended up with 2.66, which I see that I need to multiply by 3. So when I do that, I'm going to get exactly 2.66 times 3 is going to give me exactly 8. And then when I multiply 3 by 1, I get exactly 3. So my empirical formula becomes C3H8. If I add that mass up, it's going to give me 44 grams per mole. Now, in this case, 44 is not 132, but 132 has to be a multiple of 44. So if 132 is divided by 44, we find that we get a multiple of 3 again. And this time, we're going to take our empirical formula, we're going to multiply through by 3 to give us a molecular formula of C9H24. You can check your work. If you add that up, it's going to end up giving you that 132 grams per mole. So that's how you know you've got it correct. All right, so we're going to try one more thing. I'm going to try one more problem. This was a bit of a bugger. It's not done any differently than what we've done already, but it's a little bit different because it involves sodium. And this is a case where we're not really dealing with a true empirical ionic formula, I found out, and instead it's just kind of a bugger of an example, and I'm going to work it with you so that you know how to do this. Let me get a fresh pencil with a fresh point on it. So once again, we're going to write our elements down. This is sodium, this is sulfur, and this is oxygen. There's our 3 elements. And once again, just like in the first problem, I'm just going to write down my mass based on the percentages. So 20.2 grams, and this is 37.6 grams, and oxygen is 42.2 grams. So I'm going to multiply that through. Sodium is 23 grams, so 1 mole over 23, not 22, 23.0 grams for sodium. Sulfur, if I look at the periodic table above me right now, sulfur is 32.1 grams, and then oxygen, as always, is 16. All right, so once again, I'm going to get my calculator, and I'm going to find that 20.2 divided by 23.0 is going to give me 0.878. I want to keep my 3 significant figures throughout this. And then 37 divided by 32 is going to give me 1.17. Again, I'm keeping to three significant figures. And then 42 divided by 16. So 42.2 divided by 16.0 is going to give me 2.64. Alright, so once again I see that sodium has my smallest number of moles. So it's going to go into the denominator of my mole ratios. So 0.878 divided by itself is going to equal 1. 1.17 divided by 0.878. Let me get my calculator again. 1.17 divided by 0.878 is going to give me 1.33. And then finally 2.64 divided by 0.878 is going to be what? 2.64 divided by 0.878 is equal to 3. Exactly. Now here's again, look there, 0.33. What did we do up here when we had 0.33? We multiplied by 3. So that's exactly what I'm going to do. We'll multiply everything by 3. 3 times 3 is going to give us 9. 1 times 3 is going to give us 3. And then this last one, 1.33 times 3 is going to give me 3.99, which is close enough to 4. So there are my integers. So my empirical formula now is going to be Na sub 3, S sub 4, and O sub 9. And so once again, let's add this up to find out what our empirical mass is. So 16 times 9 is equal to 144, and then 32 times 4 is equal to 128. And then finally 23 times 3 is going to give me 69. So if I add those all up again, 69 plus 128 plus 144 is going to give me a mass of, so I'm just going to write EM here for empirical mass, is going to equal 341 grams per mole. Again, we see that that is not what we're given. It has to be a multiplier of that. So if we take that number and divide it into 682.8, so 682.8 divided by 341 is going to give us exactly a multiplier of 2. And so my molecular formula, sodium 3 times 2 is 6, sulfur 4 times 2 is 8, and oxygen 9 times 2 should be 18. So Na6S8 O18. And just to double check that, 18 times 16 is going to give me 288. 8 times 32 is going to give me 256. And then 6 times 23 is equal to 138. And if I add all those big numbers together, 138 plus 256 plus 288 is equal to 682 grams per mole. And that is exactly what we've gotten here, 682.8 grams per mole. Again, I was just rounding off my decimal places, but if you're a little more careful about it, it will come out to be 682.8. So guys, it doesn't matter how bad they look. Even when they look horrible, if you follow the plan, remember what I said in class, especially 5th period. Remember, follow the recipe, follow the directions. The directions are valid. If you follow those, you will get the correct answer. And just remember about the multipliers when you're dealing with the fractions you can get sometimes when you divide to make a mole ratio. Watch the video on multipliers and molecular formulas, and it's explained again in that video. Now be careful, question 4 is actually here on the very bottom, and then on the back here are 5, 6, and 7. I am going to leave those for you to do. If you have any questions, by all means email me. I can help you with it. I will try to help you with it. But again, you'll see I have done no additional steps other than what you have been seeing in class and what you have been seeing on the videos. So follow them. You'll be successful. Build a little confidence in yourselves, okay? You can do this. I have faith in you. Have a great one, guys.